So I'm Paul Linden. I'm the principal investigator of TAPAS project, which, as I hope you all know by now, is a network looking at air quality in schools and the interaction between indoor and outdoor air pollution. And we're an open network and very pleased to have as many people involved as possible. One of the things that we do, of course, is to run this seminar series on Thursdays at 1 o'clock. So very pleased you can join us. The usual housekeeping arrangements is that I will introduce our speaker, this is being recorded, so if you don't want to be recorded, please keep your camera off and stay on mute. And I'd ask you to do that anyway during the presentations for bandwidth and distraction issues. Please reserve your questions that you have and put them in the chat, and we'll go through them at the end of the presentation. Okay, so without further ado, let me say that this is with great pleasure to have Natalie Regius give us a talk today. This is actually one of our activities in TAPAS, as we funded 3 research projects, and this one is the air we share that Natalie will talk about. Natalie works in building physics and sustainable building design, having got her MRes from Lyon in France, and other work in civil engineering and building physics from Edinburgh, Napier University, where she currently is a PhD candidate in the Scottish Energy Centre, working on indoor air quality in schools. And she's done a lot of work on projects related to building performance evaluation. So highly experienced and lots of things to bring to bear on this topic. So we look forward very much to hearing what you have to say, Natalie. And I'll hand over to you if you'd like to share your screen and take it away. So thank you.
Thank you, Paul, for the introduction. So let me share my screen. Whoop, we're not at the start.
Yep, that's good.
Yeah.
You can see that perfectly. Thank you.
Okay, so I'm going to present one of the TAPAS funding project and its early findings. The project has been done over the course of the last school year in Scotland, and we have called it the Air We Share. But let's first put the project into perspective. So in March 2020, the world was hit by the COVID pandemic. After a few months of national lockdown, the City of Edinburgh Council wanted to identify which of their schools had poor ventilation and asked Napier University to survey 50 classrooms from 9 schools with different archetypes. So it was from buildings which were built during the Victorian times to 2009, and that included primary schools, high schools, special schools. 7 of these schools were naturally ventilated, where 2 had mechanical ventilation. Some measurements of indoor temperature, relative humidity, and CO2 concentration were performed over 1 week in November and December 2020. And the teachers of the classrooms were asked to fill in a document where they were put the number of pupils and the opening of the windows and doors. The conclusion of this study showed that 14 school classrooms had their CO2 levels above the 1,500 ppm threshold very regularly, 9 of which were primary school classrooms. Then in September 2021, when the TAPAS workshop took place, it was a great opportunity to meet people from different backgrounds who all wanted to improve the quality of the air at school. That is when Michelle from Milieu Architecture, Sarah from Global Sustainability Institute at Anglia Ruskin University, Rosie from the Institute of Zoology at the Zoological Society of London, and I from Edinburgh Napier University met. And we managed to win a grant to do this small pilot project in doing further investigations on how to improve indoor air in schools. To present the aim of the Air We Share, let's go back to some facts. So in March 2021, the Scottish government announced they were giving special funding to local authorities to buy CO2 sensors to be deployed in their school classrooms. But we also know that workers often complain about the lack of control over their comfort and their work environment. We know also that visual devices which help occupants to visually monitor their energy consumptions have had positive outcomes with reduced energy bills. And finally, it's known that teachers suffer the most from stress, anxiety, and depression and have an increased work-related respiratory problem. Therefore, the aim of the study was to explore the effect on the indoor air and on the teachers' comfort and behavior change when raising awareness of the influence of the indoor air and on ventilation, and also when the teachers are using visual sensors in naturally ventilated primary school classrooms. The following research questions were: can visual CO2 sensors help the teachers improve the indoor air in their classrooms? Can we ask the teachers to be in charge of managing the ventilation of their classrooms? And can CO2 sensors have perceived health benefits for the teachers? Let's give the details of the study design. So considering the findings of the previous study showing that the primary schools were studied have higher CO2 concentration, and the fact that the Edinburgh City Council manages 89 primary schools, 90% of which are naturally ventilated, we decided to study two similar Victorian primary schools with natural ventilation. The council accepted to provide access to two of their schools, which met our criteria. So Victorian primary school, naturally ventilated in the same environment. And so they were willing to take part in our study. So we've called them School T and School S, both located in the center of Edinburgh, less than 2 miles apart. 10 classrooms of School T were equipped with visual and non-visual sensors, while 10 classrooms of School S were equipped with non-visual sensors only. A total of 26 teachers have been involved in the study, 11 in School T, 15 in School S, and the study took place for almost all last school year, so from October 2021 to June 2022. The study comprised 5 different elements. So the first one consisted of listing the characteristics of each building. So an in-depth building visit of each school was done to complete the floor plans of the school, which have been provided by the council itself. That's when all the measurements and detailed information were gathered, such as surface areas, volumes, number of windows and dimensions, the number of occupants, adults, children, how old were the children, the orientation of the rooms, and so on. The second element of the study was to design surveys to study the teachers' perception of their comfort, health, and well-being. So questions related to any symptoms they could link to their classrooms were asked, but also questions on how comfortable they feel their classroom is, how they perceive the quality of the air in their classroom, and what they think about the visual sensors for the ones who had one. In addition, the professional quality of life scale, which is a fully validated psychological scale, was added to the survey. The survey received ethical approval by Edinburgh Napier, and then the 2 online surveys have been administered, one pre-intervention and the other one during an intervention, 4 months after the start of the study. Each survey took about 20 minutes to be completed. The third element of the project was to create a webinar at the intention of the teachers to explain the importance of indoor air and give some ventilation strategies appropriate to their classrooms. The fourth element was measuring the indoor environment parameters, including indoor air temperature, relative humidity, and CO2 concentrations. And finally, the last element of the project was going to visit weekly both schools to download data, to check windows, to chat with the teachers, and to take notes of anything important or relevant which could have an impact on the outcomes of the study. So the project itself had two interventions. One was deploying the visual sensors in one of the schools, and the other one was to raise the awareness about indoor air quality targeted to the teachers. So this slide gives more detail on what has been done for that. And so a 25 minutes webinar was created explaining important elements such as what is indoor air quality, what influences the quality of the air, what is an airborne virus transmitted, or how is an airborne virus transmitted, why CO2 monitors are used, and what a visual CO2 monitor looks like, what are the regulations from the Scottish government, what is good ventilation practice in a classroom, and different suggested strategies. The webinar is accessible on YouTube and the link is below. So to recap and visualize the different elements and the interventions which were part of the project, you can see the timeline here. The interventions are colored in red. So the study started in October 2021 by visiting the buildings and take notes of all the characteristics. Then the teachers have been asked to take part in the first online survey. Then the sensors, visual and non-visual, were deployed in both schools, and that was the start of the monitoring and the weekly visits. In March 2022, the teachers completed the second online survey, and at the end of the project, early June 2022, the sensors were retrieved. Now, let's look at the early findings of the measurements of the indoor parameters. Here are two graphs showing the time-weighted averages of the CO2 concentrations over the course of one school day during the heating season on your left and the non-heating season on your right for both schools. So the blue line represents the results for school T with visual sensors, and the orange lines represents the results for school S without the visual sensors. It is noticeable the CO2 concentrations are lower in school T, where the classrooms have been equipped with visual sensors, and that is the case in both seasons. If we have a look more specifically at the levels during the heating season only, the following two graphs show the averages of the CO2 concentrations, the left graph, and the indoor temperature, on the right, during the heating season for each classroom. The same colors have been used as the previous graphs, with blue being for the classrooms with the visual sensors and the orange, without. The classrooms have been organized from the smallest CO2 average to the biggest, and has been the same for the temperature. The lines are showing the averages per school. Looking at the CO2 concentration, so the graph on the left, again, the average of the school T with visual sensors is lower than the school S without visual sensors, with a difference of about 120 ppm. 4 classrooms with visual sensors have lower averages CO2 concentrations than the school average for 3 in a school with non-visual sensors. Looking at the indoor temperatures, the difference between the averages of both schools is insignificant, which tend to show when classrooms are better ventilated, doesn't necessarily mean colder temperature. But it's also possible to notice it's not necessarily colder in a classroom with lower CO2 concentration. For example, classroom T2 and T3 have lower than the average school CO2 concentrations, but they have either average or above average indoor temperature. Now looking at the classroom T7, which has a visual sensor installed in it too, it also has lower CO2 temperature and lower average indoor temperature. And so if we look more precisely at the annual CO2 concentration of this classroom, T7, which is shown on the graph, we can see that the CO2 levels are almost always below the 1,500 ppm threshold, and even below 800 ppm most of the time, except at some point towards the end of the year. I did spot this during the weekly visits, and it appeared a supply teacher was in this classroom for that period. This teacher was unaware of the webinar of ventilation strategies for this classroom and of the use of visual sensors. Again, during my weekly visits in school T with visual sensors, I have been approached by different teachers, including the usual teacher of this classroom T7, as she had issues with one of the blinds, as you can see on the picture on the left. But I did notice she always opened both panes of both windows, which explains the low CO2 concentrations and the low indoor temperature in her classroom. Other teachers didn't put this ventilation strategy into practice, as the picture on the right shows, where only the bottom panes were open. Other teachers in classroom T2 and T3 did say they kept the upper pane open all the time and used the visual sensors to decide when to open the bottom panes. This helped keep the CO2 concentrations low with a more acceptable indoor temperature. These findings and observations show the importance of understanding how to ventilate properly and how to use visual sensors accordingly. Now moving on to the results of the online surveys. So early results, which everything has not been analyzed yet, but some analysis, so yeah. The two graphs on this slide show the teachers' perceived comfort of their work environment pre-intervention at the very start of the study, before the webinar and before the deployment of the sensors, and 4 months after the start of the study for both schools. It is noticeable the teachers from school S with no visual sensors perceive the same level of comfort pre and post-intervention. On the other hand, the teachers from school T equipped with visual sensors perceive their work indoor environment as less comfortable post-intervention, even if one person, which represents the 9% in green, as you can see on the graph on the right, who feels it's more comfortable than at the start of the study. This graph, again, looking at the results of the survey, illustrates the percentage of the time the teachers feel cold in their classrooms in winter, from both schools pre and post-intervention. The teachers from both schools have the feeling their classrooms are colder more frequently post-intervention. This correlates with the comments they wrote in the survey and also with what they told me during my weekly visits. From these early findings, it's possible to conclude that raising the awareness of the teachers about good ventilation practice for their own classrooms, improved the air quality as quantified by reduced CO2 concentration. The visual CO2 sensor helped the teachers who had them and used them to improve and maintain lower CO2 concentrations. But more ventilation reduced the comfort levels of the teachers during the heating season. They found their indoor working environment less comfortable and colder more frequently in winter. Some analyses are still ongoing, especially on the surveys, but the full results of the study will be accessible on a dedicated website, which is under development. A blog will also be part of the website. Following the Air We Share project and the article I've published about the preliminary study I've talked about at the start of this presentation, high schools in Scotland have been in contact to have some support to improve the indoor air of their classrooms. They have asked for webinars and STEM activities to be built in collaboration with their teachers. I am hoping to start this new chapter in the next school year. Thank you.